Hydrogen, numero uno in the periodic table, practically elemental royalty. It may be the smallest atom in the universe, but it could have the power to save the planet.
It's key to us moving to a clean energy future,
providing us with an unfathomable amount of energy.
It's a potentially almost limitless source of energy,
whilst also having the potential to bring life as we know it to a grinding halt.
Man had firmly in his grasp the forces of progress and his own destruction.
But how can something from the very dawn of time itself, formed just minutes after the Big Bang, be both the key to our salvation and our extinction? The answer to that question is written in the stars.
In order for stars to burn and shine for billions of years, they convert hydrogen into helium through constant nuclear reaction.
This process is known as fusion, where atoms slam together to form a heavier element. We used to think the Sun was compositionally identical to Earth, until Cecilia Payne-Gaposchkin concluded in 1925 that stars are almost entirely composed of hydrogen and helium, meaning our Sun is literally a giant fusion reactor.
This was a huge shock during this time. In fact, one of the preeminent physicists of the day, Henry Norris Russell, told her this was wrong and that she should omit it from her PhD thesis at Harvard. And she left it in, but she ultimately called her results almost certainly not real. Frustratingly, a few years later, this same physicist, Russell, later changed his mind, recognized Cecilia was correct, and published his own results in his own paper. And he ended up largely receiving credit for this discovery for quite some time, due in part to the fact that Cecilia was not afforded status at Harvard University on account of being a woman.
Classic. Something she noted in her autobiography.
I note it here as a warning to the young. If you are sure of your facts, you should defend your position.
Just a note to all self-doubters. Although tiny, the power released by hydrogen atoms is staggering, with potentially limitless applications. Alas, so far on Earth, humans have mostly used it for annihilation. This is IV Mike, the first full-scale hydrogen bomb test. In 1952, the US blew Mike up on the Pacific Marshall Islands. It vaporized an entire island and left a crater more than a mile wide. Hydrogen bombs are the most powerful weapons humans have ever created. Roughly 1,000 times more powerful than the atomic bombs that flattened Hiroshima and Nagasaki and killed more than 200,000 people. And 6 countries are confirmed to have them: the United States, Russia, the United Kingdom, China, France, and India. And whilst so far none of them have been used in battle, they remain a persistent threat to life as we know it. But some people believe that we could use this immense hydrogen power for good.
We would like to create a star in a jar. So the reason we want nuclear fusion to work is that it's a potentially almost limitless source of energy that doesn't release carbon.
But there's just one small problem with this method.
It doesn't work yet. It's a very long-term project, right? And we have a very near-term issue of climate change.
Whilst work is being done internationally in France in the form of the ITER project, an international nuclear fusion research project focusing on building the world's largest experimental fusion reactor by 2025, we are still a long way away from developing fusion here on Earth. Luckily, hydrogen may pose the answer to our climate problems in other ways, as an alternative to fossil fuels.
What's exciting about hydrogen is that we can burn it without releasing any CO2 because there's no carbon in the system.
In theory, burning hydrogen produces almost entirely water vapor, pure green energy. That's why it's such a buzzword right now. It has the potential to help power our cars, ships, planes, trucks. Governments around the world have pinned their net zero hopes on hydrogen. And many say hydrogen is key to meeting the goals of the Paris Agreement. But there's a problem. For all hydrogen's abundance in the universe, we have to make the hydrogen we burn ourselves. And that's where it gets a bit tricky. Because it turns out our wonderful source of green energy isn't always so green. In fact, it's more like a Jackson Pollock painting.
So hydrogen is only as clean as where it comes from. And to figure out where it comes from, we could look at a color chart.
Whilst hydrogen is colourless, we use colour codes to identify different types. There's grey, brown and turquoise hydrogen, which are all produced using fossil fuels. There's blue hydrogen, which is also produced from fossil fuels, but the emissions produced can be recaptured and stored underground. Or yellow and pink hydrogen, which are generated through electrolysis and nuclear power, respectively. And then, of course, there's our good friend green hydrogen, which produces no harmful greenhouse gas emissions. But here's the kicker.
Unfortunately, about 95% or more hydrogen today is made from some sort of a hydrocarbon source.
Even blue hydrogen, the one where you supposedly recapture the CO2 released, emits 20% more carbon than simply burning the gas for heat, because even the carbon capture process itself includes burning natural gas. So yeah, to make our wonderful fossil fuel alternative, we're using a fossil fuel. That doesn't sound right. The obvious answer, of course, is to use green hydrogen, the type made from clean renewable energy through electrolysis. The problem is, that's really expensive. But green hydrogen can also be used to store renewable energy. And this is where it may help save the planet.
Renewable energy is intermittent, and so we need a way to store that energy so that we can actually provide a stable electrical grid. We can take excess electricity from the grid, make hydrogen, and then store that hydrogen for times where the demand on the grid is higher than the grid can produce.
But you can also use hydrogen directly in vehicles. Japan, Germany, the US and Orkney already have hydrogen refueling stations where you can top up your vehicle. And tests are already underway on planes powered by hydrogen fuel cells. But let's not overreach here, because hydrogen still has another major hurdle to overcome: energy density. Put simply, it means that hydrogen takes up more space to produce the same energy as something like methane, which is bad because it makes it less economically viable. Say you're looking to transport a load of cargo on a ship. You want to move as much stuff as possible for as little money as is needed. Hydrogen might take up 20% of that space, but something like methane or a fossil fuel takes up just 5%, which leaves more room to transport cargo. But what if there was another way of storing that energy?
So another avenue is to take that excess electricity, and instead of producing hydrogen, we produce a metal like aluminum. We can take that aluminum, react it with the water that the boat is floating on, and produce heat and hydrogen on demand. So we get to use it, but we don't need to store it or transport it. And by it, I mean hydrogen.
So even though hydrogen may not immediately seem like a magic bullet when it comes to green energy, and let's be honest, it's not. It can and will play a part in the solution to saving our planet. If we make hydrogen using the water we have all around us, we can produce a potentially infinite amount of green energy. And it's amazing to think that all this power, with its tremendous applications, can come from this teeny tiny little atom, the smallest in the universe, but just quite possibly the most significant.